let's get started here on your review for the rational exponents and radical tests coming up. All right, so in number 1, we're finding the value of the variable that makes the equation true. So for the first one, 3 to the a is equal to 81. So here's the power table. 3 to the second is 9, 3 to the third is 27. So you need one more 3 to get to 81. So that means since 3 to the fourth is 81, a is equal to 4. For b, when you divide powers with the same base, you subtract the exponents. And so we've got 5 to the fifth divided by 5 to the negative 2. So that means we need to figure out what 5 minus negative 2 is. So that's how we would get the b. And so 5 minus negative 2 is going to equal 7, so b equals 7. On c, when you multiply powers with the same base, you add their exponents. So that means that c plus 4 is equal to 10. And so c is equal to 10 minus 4, 6. And on d here, when you multiply powers with different bases but the same exponent, you can multiply the bases and the exponent stays the same. So that means that d is equal to 8 times 2, or 16. All right, next we're going to look at expressions that are equivalent to 49 to the 1/2. So remember that rational or fraction exponents are another way to represent roots. The bottom or denominator of the fraction exponent is the type of root. So 49 to the 1/2 is a different representation for the square root of 49. So I'm going to select the square root of 49. And I know the square root of 49 is 7. So I'm also going to select 7. So then I'm kind of thinking about, like, could that be equal to 7? No. Could that be equal to 7? No. The square root of 7 and 7 are not the same thing. So far, just those two. And then if we look at this last one here, we want to go ahead and simplify that a little bit. When you raise a power to a power, you multiply the exponents. So this is equal to 49. And then 1/4 times 2 is 2/4, which is the same thing as 1/2. All right, so then this is going to be another one to select. All right, next we're going to evaluate. And our final answer should not include exponents. So the first thing I'm going to do is kind of like what we were doing up here. We've got a power to a power. So when you raise a power to a power, you multiply the exponents. So 3 to the 3/2 to the second is equal to 3. 3/2 times 2 is 6/2. And I can divide 6 by 2 evenly. This is equal to 3 to the third, right? Because 6 divided by 2 is 3. And then you can use the power table. 3 to the third is 27. So final answer is 27. All right, so number 4, we're using radical notation for 6 to the 5/3. Again, that denominator of the fraction exponent is the type of root. So I know this is a cubed root. So that's going to be the index, the little number on the root. 6 remains the base, so it goes underneath. And then 5 is the exponent. So that's one way you could write it. Or you could also say the cubed root of 6 and then raised to the 5th, the whole thing. So that exponent of 5 could be under the root or out of the root. All right, number 5, we're going to write 3 to the negative 3/4 without using exponents. So there's kind of a lot going on here. We've got a fraction exponent, and it's also negative. So I'm going to address the negative part first. So this negative exponent means, I'm going to kind of write it over here. So we have 3 to the negative 3/4. So the first thing I'm going to do is rewrite this as a fraction. When we do that, that makes the exponent positive 3/4. Okay, now I'm going to address this exponent, but it's still a fraction. Once I make it into a fraction, it's going to stay a fraction the whole time. So 1 over, it's the 4th root, because 4 was the denominator of the fraction exponent, of 3 to the 3rd. And we're almost there. It says without exponents. So since this is like, it's in the power table, we already did 3 to the 3rd up in this problem. So final answer is 1 over the 4th root. 3 to the 3rd is 27. All right, and then that would be the final answer. Okay, number 6, we're going to go the other way around. Write the 6th root of 16 to the 4th without radicals. So 16 is our base. And then it's a 6th root, so that's going to be the denominator of the fraction exponent. And then 4 goes on the top. 4 is the numerator of the fraction exponent. So you have some options. This is a totally acceptable answer. I always like to reduce a fraction if I can. And so I would reduce this as 16 to the 2/3. They're totally equivalent. You can have it either way. All right. Next, okay, so we've got this data table. The function is y equals 9 to the x. So this number in the top is the x value. It's the exponent. And then the y value is 9 to that power. Okay? So let's see here. I think I'm going to start at 0 because I know 9 to the 0 is equal to 1 because anything to the 0 power is equal to 1. So then with our exponent of -1, 9 to the -1, that means this is going to be a fraction. 1 over, you can write 9 to the 1st, or which is just 9, okay? Going in this direction, 81 is equal to 9 squared. So I know this is the same thing as 1 over 9 to the 2nd, which means our exponent is going to be -2 because that's how we get a fraction. And then this means 9 to the -3, or 1 over 9 to the 3rd. And so looking at the power table, here's 9. 9 to the 3rd is 729. So this is 1 over 729. Okay. All right, so moving in the other direction, this would just be a power of 1. And then here, when x is 2, 9 to the 2nd is 81. And we just saw in the power table, 729 is equal to 9 to the 3rd. So this is a 3 here. All right, I'm going to get a different paper for the back side. So that's kind of it for using the exponent properties and then like our rational exponents, our fraction exponents that we were working with earlier in the unit. The second part of the review is all about solving equations. Okay, so I'm just going to step through each of these. Here we go. So on number 8, use the graph to solve the equation, the cubed root of x is equal to 2. So here we have this equation, and it's saying, when is this equal to positive 2? So here's positive 2. So this number, we're looking for the x. This is the y. See how that looks in the function? The number here, the 2, represents the y. So here's 2 on the y-axis. I'm going to follow it till it intersects the graph. Okay, so if I have to mark on the graph where the solution is, I'm going to mark right here. And sometimes on a graph, like on this graph, we can clearly see it's 8, but sometimes it's like out in the middle and it's hard to read. But you should still have an exact answer, because if this is our equation, then x is equal to 2 to the third. And 2 to the third is exactly 8. Okay, so there should be no question, even if it's like in the middle of 2 places on the graph and you can't quite read it, there should be absolutely no question to the value of x, because you can use that exponent and find the exact value. So you're giving the representation on the graph, and then you're also finding the exact value using an exponent. All right, next question here is about solving an equation and getting the solution. So we need to figure out if we agree or something went wrong. So let's look at the steps. So something squared is equal to 64. So the first thing to do would be to square root. Okay, but what I see right here already is that when you take the square root of a number, you have to remember every positive number has 2 square roots, a positive one and a negative one. And so at this point right here, when they're taking, or Paula is taking the square root of 64, Paula forgot the square root of 64 has a positive and negative value. 8 times 8 is 64, but also negative 8 times negative 8 is 64. So she found this solution, which it looks like she did correctly. The square root of 64 is 8. Take away the 9, and you get negative 1. So this one is correct, but she forgot to solve x plus 9 equals negative 8. So we're going to subtract the 9 here as well. And negative 8 minus 9 is negative 17. All right, so I agree, but she has another solution to find. So she should have x equals negative 1 and negative 17. All right. So let's get to the equations down here. And before we start these equations, I just want to kind of remember what these functions look like. So what does a square root, a cubed root, an x squared, or an x to the third, what do those functions look like? All right, so I'm going to grab myself this Post-it here. Maybe. Here. Okay, so let's review what they look like. So for y equals x squared, I'm just going to write x squared. X squared graphs go up on both sides. They don't exist in the negative area. So if we have x squared is equal to a positive value, there's going to be 2 solutions. If we have x squared is equal to a negative value, there's no solution. And if we have x squared is equal to 0, there's going to be 1 solution. I'm not going to worry too much about that one. Okay, so that's what x squared graphs look like. The square root of x, those graphs, it's kind of like this on its side, but only half of it. That's it. So if we have the square root of x is equal to a positive number, there's 1 solution. But if it's equal to a negative number, there's no solution. It doesn't touch the graph. And then when we get to x to the third and the cubed root of x, these functions, so x to the third looks like x squared on the right side, but on the left side, it kind of twists down instead. So no matter what value you've got, if it's positive or if it's negative, these always have one solution. Always. Always exactly one. They never have no solution. They never have two solutions. They only ever have one solution. The cubed root of x is really similar to that. And so the cubed root of x looks like the square root of x on one side, but then it also has like this other side. So the same thing happens with the cubed root of x, is that these functions always have one solution. No matter if the cubed root of x is equal to a positive number or a negative number, there's always one solution. So knowing that, let's go through these equations. So my first equation, I've got a square root equal to a negative number. Square roots will never equal a negative number. There's no solution. I'm not even going to do any work because there's no solution. This is positive, this is negative. Okay? On B, it's a cubed root equation. These always have one solution. Let's find it. So I have to get this cubed root of 5x by itself first. I'm going to do that by adding the 2 to both sides of the equation. So that's 0, and I have the cubed root of 5x is equal to 3 plus 2 is 5. Okay? Now, the next thing is to go ahead and use an exponent. The 5x has to stay together until we've gotten rid of the radical. So the next step is the exponent of 3 because this is cubed root. So when we raise this side to the third power, we get 5x. And then 5 to the third, you can look at the power table. 5 to the third is 125. Okay? So 5 to the third is 125. And then finally, 5x is 5 times x, so we're going to divide by 5. And 125 divided by 5 is 25. So x equals 25. All right, next we've got the cubed root of 2x plus 7 is equal to negative 3. So again, this is a cubed root equation. Cubed root equations always have one solution. 1. All right, we have to get the cubed root of 2x by itself. So subtract the 7 from both sides, and you get this is 0, and you get the cubed root of 2x equals negative 3 minus 7 is negative 10. All right, before we can divide by 2, we have to use an exponent to get rid of the radical. So we've got we've got to cube both sides of the equation. So when we cube over here, we just get the 2x. And then negative 10 to the third is negative 1,000. Right? When you cube a negative number, you get a negative answer. All right. So now we've got 2 times x. 2x is equal to negative 1,000. So divide by the 2. Negative 1,000 divided by 2 is negative 500. All right, let's go to D. So on D, we've got x plus 4 in parentheses squared, but this is the same type of function as that because it's being squared. And so we can look at this graph here to think about it. I've got something squared and it's equal to a negative number. So something squared equal to a negative number doesn't have any solutions because the graph doesn't go down to the negative side. So 0. And that's it. All right, let's move on to E. We've got another x squared type of equation on E. This time it's equal to 55, but before I can state how many solutions there's going to be, I want to go ahead and move the constant over. The plus 6 needs to go to the other side. So I'm going to start by subtracting the 6 on both sides of the equation. And so the x plus 3 squared comes down. And that's equal to 55 minus 6 is 49. Okay, so now I've got something squared is equal to 49. This is a positive number, so there's going to be 2 solutions. All right, so first I have to remember, now I'm going to square root to get the x plus 3 out of the parentheses. But 49 has a positive and negative square root. So I have 2 options. I have x plus 3 equals 7, and x plus 3 equals negative 7. So those are the 2 roots, excuse me, of 49. Okay, so we solved both of these by subtracting the 3. That's going to give us a value of 4. And over here, negative 7 minus 3 is equal to negative 10. So those are the 2 solutions there. All right. Excuse me. Okay. Sorry. All right. So on F, this is a square root equation. Square root equations have to be equal to a positive number to have a solution. It looks like it's equal to a negative number, but this minus 9 is on the outside of the square root. So we're going to add it over first. And notice now we have the square root of x minus 11 equals negative 6 plus 9 is positive 3. So this will have 1 solution. Because as long as we've got a square root equal to a positive number, there's 1 solution. All right, so let's find that solution. We're going to start by squaring both sides of the equation. That gets rid of the radical here, so we have x minus 11. 3 squared is 9. And so from here, you're going to add the 11 over, and you get x equals 20. All right, we're almost there. Let's look at the last 2 equations. So for G, 2x to the third plus 1 equals negative 15. So this is an x to the third equation. They always have 1 solution. So the first step is to subtract the 1 from both sides because we're trying to get this x to the third by itself. So subtracting the 1, and we have 2x to the third is equal to negative 15 minus 1 is negative 16. All right. Now, I know I'm going to use a cubed root to get x to the third to be just x, but before we can do that, you have to have x to the third completely by itself. It's currently being multiplied by 2. So we have to divide by the 2 And that gives us x to the third is equal to negative 8. And so x is equal to the cubed root of negative 8. And the cubed root of negative 8 is negative 2. So final answer, x equals negative 2. And we're on the last problem. Okay, so we've got something squared equal to a positive number. So we're going to have two solutions. And let's see that the squared part of the equation is already on its own side of the equal sign. So it's already isolated. We can go ahead and use a square root. And so when we square root here, we get x minus 8. And then remember 36 has two square roots, a positive one and a negative one. So we've got two equations to solve. X minus 8 equals 6. X minus 8 equals negative 6. So add the 8 over here, and we get x equals, excuse me, 6 plus 8 is 14. And then add the 8 on this one. And negative 6 plus 8 is 2. All right, so our two solutions, x equals 14 and 2. All right, so that is the end of your review. I hope this was helpful. You guys have worked really hard in this unit, so I'm hoping that you study hard and you do super well tomorrow. All right.